Hi guys, we're going to be classifying triangles. Pardon me, I was just getting into some Oreos. Oh, okay, so we're going to use the triangle inequality theorem. It's going to be really fun to see if I can remember what goes in the blanks tonight. So feel free to laugh at me at home. Okay, inequality. Inequality. Okay, we're going to classify triangles by angle measure and by side length. Okay, and we're going to use the triangle angle sum theorem and the exterior angle sum theorem. Okay, so you're supposed to remember that a triangle is a polygon with 3 sides. Now, I don't know that we ever really addressed this, but a polygon is a closed figure. Closed figure. Okay, so like this, that's not a triangle. Okay. All right. It's not a polygon either. It's got to be closed. Okay, so AB, segment AB, segment AC, segment CB are the sides of this triangle ABC. And points A, B, and C are the vertices. Just a little vocab review. Okay, so the triangle inequality theorem says that the sum of any 2 side lengths for a triangle has to be greater than the length of the third side. Okay, so AB and BC have to be greater than AC, BC and AC have to be greater than AB, and so on. Okay, so we have to apply that and see if we can make triangles that have these lengths. So we're just going to do 3 tests. We're going to see if 7 plus 10 is greater than 19. And I'm getting 17, and it's not greater than 19. Okay, so by the triangle inequality theorem, I could not make a triangle out of these sides. It would be a goofy looking one where they didn't touch. Okay, they wouldn't be a closed figure. So this is a no. 7 plus 10 is not greater than 19. Okay, let's try another one. All right, so we've got, not 8, 8 plus 13. Is that greater than 21? Okay, no, it's not. It's equal to 21. So this is actually 21 is greater than 21. And we know that this is false, okay? This did not make a true inequality. So we can say that 8, we can say no, 8 plus 13 is not greater than, oh my goodness, greater than 21. Okay, last but not least, we've got this goofy little triangle. So we have to test until we get a fail. And if it doesn't fail, then we know it works. So is 2 plus 16 greater than 17? Well, yeah. 18 is greater than 17? Yes. All right, what about is 16 plus 17 greater than 2? Oh, heck yeah. Way bigger. All right, last but not least, is 17 plus 2 greater than 16? Ding, 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 ding. Winner, winner. Okay, so this is going to be yes. because each sum of two sides is greater than the third side. Okay, so that's how it works. All right, so if you want to think about what that would look like, it would be like this tall, skinny little triangle, okay, with one side just like the 17 side is just slightly longer than the 16, and then the 2 is this little mini side. This is the goofiest looking triangle you ever saw, but it works. All right, next. Triangles can be classified in two ways. Okay, we can go by their angle measures or by their side lengths. And as you can tell, we're going to talk about angle measure first. Okay, so acute triangles need 3 acute angles. So they all have to be acute, otherwise they're not cute at all. Okay. An equiangular triangle has 3 congruent acute angles. So you can see right here, equal angles, right? They all 3 have to be equal. Okay. A right triangle, you can see that we've got a 90-degree angle in here, has just one right angle. It can't really have 2 because it has to add up to 180, right? So if you had 2 right angles, I mean, you wouldn't have a third angle. So it just gets 1. Okay. Obtuse triangle has just one obtuse angle. The other 2 have to be acute just because there's only so many degrees to go around. It just gets one big obtuse angle, that guy. All right. So we're going to do a little bit of solving in the triangle and try to classify each triangle by its angle measures. So triangle ADC, that's this one right here. Triangle ADC, that is a right triangle because it's 90 degrees. Right triangle. All right, next we have triangle ABD. ABD. I realized that I only did like 3 sides of that triangle. It should have been like this. Sorry, it should have been the whole thing. The whole thing is a right triangle. Okay, let's do ABD now. Okay, ABD. All right, so ABD has an 80-degree. What am I looking at? Let's come back to ABD. Let's do BDC first. So BDC is this one. Let me not use that same color blue. How about that? This guy. This triangle is so long and skinny, it's kind of hard to see. Okay, so we've got 100 degrees. We've got 10 degrees. So this part over here has to be 180 minus 100 minus 10. So what is that? 70? 70 degrees. Okay, awesome. So it's got 2 acute angles and 1 obtuse angle, and it just takes 1. So this one is obtuse. All right, now I'm ready to talk about the other one. All right, so we figured out that this guy's 70. Okay, its complement in the 90-degree angle is 20. Okay, 20 and 70 make 90. And so what does the other angle have to be? So 180 minus 80 minus 20. 180 minus 80 is 100, minus 20 is 80. 80. So I have two 80-degree angles in here. Okay, so 20, 80, and 80, those are all acute. So triangle ABD is an acute angle. Triangle. That's probably going to happen a lot until I get used to saying triangle instead of angle. Okay, let's try another one. This picture is easier to see. I don't care for that picture, if I'm honest. Classify each triangle by its angle measures. Okay, well, we know how to do that now. So EHG, triangle EHG, that's this one. Oh, geez. All right, I got a 30, I got a 60, and over in this corner, for that angle, we got a 90. So EHG is a right triangle. All right, next, FHG. FHG. Okay, so we don't know what this little guy is yet, but we know that this little guy plus 30 add up to 90. So 30 plus my unknown angle make 90. That means my unknown angle has to be 60. 60 degrees. So if they are all congruent, then FHG is equiangular. Equiangular. All right, next, EHF. Last but not least, that's this one. Okay, so angle EFH, this one here, makes a linear pair with the 60-degree angle. So 180 minus 60 is 120. So we have an obtuse angle right there. This guy is obtuse. Oh, that's the worst triangle ever. Okay. All right, that's it. Okay, now we're going to go by side lengths. All right, triangle classification by side lengths. We have an equilateral triangle with 1, 2, 3 congruent sides. No surprise there. Isosceles has at least 2 congruent sides. Okay, there's that special phrase, at least. So what you're going to find is that every equilateral triangle is also isosceles. Every equilateral is also isosceles. Because if it's got 3 congruent sides, that is definitely at least 2. All right, last but not least, we've got scalene triangles that have, I think it's no congruent sides. I don't think I put 0. I think it's no. Okay, we'll see. All right, so don't assume. when you look at a figure, you cannot assume segments are congruent based on their appearance. We already know this from Unit 1. Okay, it's going to be the same thing. We can't assume. The figure may or may not be drawn to scale. Sides must be marked as congruent. Okay? We can't tell just by eyeballing it. We have to have it marked. Or from the markings or a given, we can make a series of logical deductions, right? Like we can figure out, but we can't just like, oh, looks right. No, you can't do that. All right. Classify the triangle by its sides. Okay, EHG. EHG, that's the big one. Okay, so it's got this whole side looks like a 14, 4 and 10, 4 and 10, and a 12 and an 11. So this one is scalene. Okay. EHF. That's this one. So we know that it's got these two congruent sides, okay, but not three congruent sides. So it is isosceles. Okay. FHG. FHG. So I've got a 10, a 4, and 11. We got another scalene. Ta-da! All right, look over here. Classify the triangle by its side lengths. Okay, ACD, triangle ACD. That's this crazy looking one. All right, well, I got a 5 and 18, and then this one is marked as congruent to this one, so it also has to be 15. Okay, so that is scalene. All right, now for ABD, did I mean it to be ABD? Huh. All right, we're going to add one after we do ABD. All right, for ABD, that's the big outside triangle. ABD. Okay, we got a 15, and this isn't 15, it's 20, because it's 15 plus 5. So this one is also scalene. All right, let's add one more. We're going to do triangle ABC. ABC, easy as 1, 2, 3. ABC. Okay, so I got a 15, a 15, and 15. It's equilateral. I wonder if it was in the notes and I accidentally deleted it. So I'm going to add it back for you guys because I want you guys to have that one. Sweet. All right, we got to talk about the triangle sum theorem. We kind of have already addressed this, but the sum of a triangle's interior angle measures is 180. Okay, so for this triangle that we have here, we can say the measure of angle A plus the measure of angle B plus the measure of angle C has to add up to 180 degrees. Okay, so we're going to use that triangle angle sum theorem to find each angle measure. So the first one we want is the measure of angle XYZ. XYZ, that's this angle here. All right, so if I'm adding up to 180, I want 62 plus 40 plus measure of angle X, Y, Z to add to 180. Okay, so I've got like terms to combine. I think that's 102. 102 plus the measure of angle X, Y, Z is 180. Subtract 102 from 180. I'm getting 78 in my brain. So I'm going to say 78. 78 degrees. Right? 102 plus 78 is 180. Yeah, that's right. Okay. Next, measure of YWZ. YWZ. That's this one. Okay. Well, we can use the fact that we just found the 78 degree angle. This one we now know is 78 degrees. Okay. Which makes this whole angle here, angle WYZ, measure of angle WYZ is 78 plus 12. Oh, shoot, guys, that's 90 degrees. That's a right angle. Okay, so now we know 90, we know 40. Okay, what does this angle W have to be to add up to 180? So measure of angle W plus 90 plus 40 is 180. So combine the 90 and 40. Oh, shoot. What is that? 130? 130, subtract 130 from both sides and you get 50. So the measure of angle YWZ is 50 degrees. WXY. Oh, geez. All right. So this one was 50 degrees, and now we want this one. What's that one? Well, that one forms a linear pair with 62 degrees, so what's 180 minus the 62 degrees? Oh, 180 minus 60 is 120, minus 2 is 118. 118 degrees. If that's not right, don't tell me. The shame would kill me. All right. Yes. Oh, I guess we technically used like linear pairs or supplementary to do that last one. We could have figured it out though. Okay, look. We can figure it out using the triangle angle sum theorem because look, 50 and 12, they make 62, right? So it's still the same thing. We would just subtract 62 from 180. Okay, we did it. We followed the rules. Good. Next. I'm not sure why we need this yet. I know it's going to be important. It was in the notes, and I left it in here so that we could talk about it, but I don't know that we've had to use it. We'll have to use it yet, and I'm like through half of the notes almost. We'll see. All right, so this is a fun word to say, an auxiliary line. Auxiliary line. And it's a line that you add to a figure to aid in a proof. Okay, so the reason you would do something like this is if you could add a line that was parallel to one of your sides, okay, then all kinds of angle relationships start popping out. Okay, because now I don't just have a bunch of weird angles. I have alternate interior angles here that are suddenly congruent. Yes. Okay, I've got another pair of alternate interior angles that are suddenly congruent. Boom, boom, boom. Okay, and if I am needing help solving a triangle, I can use that auxiliary line and get all those fun angle relationships to exploit. All right, next. Corollaries to the triangle sum theorem. Okay, a corollary, it's a fun word to say. Corollary. Nope, one R. One R, avoidance. Two L's. Two L's, one R. Oh, my brain didn't want to do it. It is a theorem whose proof follows directly from another theorem. Okay, so they're kind of like logical consequences from another theorem. So now that we have the triangle sum theorem, there are some other theorems that we get just because we already have that one. They're kind of like bonus. So one of them is that the acute angles of a right triangle are complementary. Oh my goodness. Okay, so if you've got a right angle, okay, which is 90, and they all have to add up to 180, there's only 90 degrees left for the other two angles to share. So they have to be complementary and add up to 90 degrees. It just makes sense. Okay, so the measure of angle D plus the measure of angle E has to be 90 degrees. They're complementary. All right, here's another fun one. The measure of each angle of an equiangular triangle is, well, let's see if we can figure it out. Okay, if they're all equal, that means I have to divide 180 by 3 equal angles. So 180 divided by 3, it is 60 degrees. Okay, so we know that the measure of angle A equals the measure of angle B equals the measure of angle C, and they all equal 60 degrees. Cool. All right, so we have talked about the interior of an angle. Okay, we've talked about the interior between two parallel lines. Now we are going to talk about the interior of a figure. And it's just what you think it is. It's the set of all points that are inside the figure. Okay, the exterior is going to be the set of all points outside the figure, which makes sense. It would be weird if it was anything else. An interior angle is formed by two sides of a triangle. Okay, an exterior angle is formed by one side of the triangle and the extension of an adjacent side. So what that looks like is, let's say I have this triangle. Okay, so I've got my one side. Here's my one side. Okay, and then my extension. This is my extension. That was the worst E. Okay, so the angle formed by those is this one here. This is the exterior angle. Okay. Each exterior angle has two remote interior angles. Okay, think about when you use your remote on the TV, you can be far away. Okay, so remote interior angles are not the adjacent one that's right next to it. It's the ones that are far away on the other side of the room with the TV. Okay, a remote interior angle is an interior angle that is not adjacent. Oh, we just said that. Okay, so here's a better picture than my sad little picture. Let's just skip over that sad little picture right now. Forget that ever happened. Here is our exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. Okay, so this is the exterior angle. And these angles, 1 and 2, are the remote interior angles. Remote interior angles. Okay, and what this is saying is that that sum of the adding up the interior angles, the remote ones, equals the measure of the exterior angle. Let's think about why this has to be. Okay, look, if I add up, let me not do blue. If I add 1, 2, and 3, I get 180 because of the triangle angle sum theorem. Okay, what do I get if I add up 3 and 4? Also 180 because they are a linear pair and linear pairs are supplementary. Okay, this is why. This is why they're congruent. So what we want to say is the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. Okay, that's not so bad. Now we're just going to find some values using our fun theorems. So we have to use the exterior angle theorem to find the measure of each specified angle. So for the first one, we want angle U. So I know that 120, which is my exterior angle, has to equal the sum, that means add, my remote interior angles. So the remote ones are angle U and angle T. So the measure of angle U plus, what is that? I think it's 50. All right, we're going to go with 50. If it's not 50, I'm sorry. It's really blurry on my page. Okay, so now I just have to subtract away the 50 from both sides and find the measure of angle U. Minus 50, minus 50. That gives me 70 degrees for the measure of angle U. Done. All right, let's find the measure of this other angle U. Oh, this one's way easier. Okay, they gave us the remote interior angles, so we just have to add them together and get the exterior angle. So 70 plus, is this the same picture? This might be the same picture, guys. They might have just spun it on me. Somebody's messing with me. 70 plus 50 equals 120 degrees. All right, so the measure of angle U is 120 degrees. Somebody somewhere is laughing at me right now. It's fine. Good pictures are hard to find. Okay. Okay, so these look awfully close together, these two, but this one right here is the adjacent. Let's not call it A. Let's just label it adjacent. Okay, so even though that side is like really short, right? This is still remote, and this is still remote. Well, this one's obviously remote, but they both are. Okay, so I know that my exterior angle, 5x plus minus 5x minus 60, has to equal the sum of my two remote interior angles. So 2x plus 3 plus 15. So I'm going to combine my like terms. 3 plus 15, that's 18. Okay. Let's add 60 to both sides. I got 5x equals 2x plus 78. Subtract 2x from both sides. We got 3x equals 78. I think that goes in evenly, but I have no idea how many times. 78 divided by 3. 26. X is 26. Okay, before I get too excited, we're not done yet because we have to find angle B. So we have to plug that in. This is always when I would forget to plug it in as a kid and then be really mad at myself for only getting like half of the points. So I have to do 2x plus 3, but we now know that x is 26. So I'm going to do 2 times 26 plus 3. And it's 55. So the measure of angle B is 55 degrees. Okay, the measure of angle ACD. ACD. Ooh, this one's fun. All right, so here is my exterior. We'll call that EX. Okay, and then here are my two remote interiors, R and R. Those are both the remotes. So if I add the remotes together, I have to get the exterior one. So this one is 90 because those are perpendicular. All right, so I have 2z plus 1 plus 90 has to add up to 6z minus 9. Let's do some combining of the like terms. We get 91. Okay, subtract 91 from both. No, I don't want to do that. I want to use positive numbers because I'm tired. All right, we're going to add 9 to both sides. Add 9 to both sides, and I get 2z plus 100 equals 6z. Okay, subtract 2z from both sides. I get 100 equals 4z. Divide both sides by 4. And I get 25 equals z. Okay, I'm not done yet because I still have to find that angle. So I have to plug it in. I have to plug this 25 in up here to find angle ACD. So 2 times 25 plus 1, I'm getting 51 degrees. So the measure of angle ACD equals 51 degrees. Is that the end? Yes, I think it is. We survived. We made it.